Good morning. Today we're going to be talking about theoretical and experimental probability. The first one we're going to take a look at is theoretical probability. And that is when we're looking at what could possibly happen. Not what did happen, but what could possibly happen. And we can do this when all the outcomes are equally likely. In other words, there's nothing that is skewing it, nothing that's been given an advantage in some way. So the probability that a certain thing occurs, so that certain thing is called the event. And so the favorable outcomes are the outcomes that satisfy that event. So say I was rolling the dice and I really needed a 6. What is the probability that a 6 will occur? Well, there would be one of each time on the dice there's 1 6. The number of possible outcomes is the number of outcomes in the sample space. And on a dice there are 6 sides. My sample space would be a 6. So for instance, let's take a look at what it would be like with that die. So on a die we have a 1, a 2, a 3, a 4, a 5, and a 6. So the first one we're looking at is the probability that we roll a 5. Well, on my die, there's only 1 5, but there are 6 possible sides. So my probability is 1 out of 6. You could also change that into a decimal and think about it as a percent if you wanted to. And you could say that there is a 17% probability that would happen. So 1 in 6 chance, or 17% likelihood that it would happen. The probability that it lands on an even number, well, there are still 6 sides to my die, but you see that my even numbers are 2, 4, and 6. So I have 3 of those. Now, when you write it as a fraction, you have to make sure that you reduce it into simplest terms if possible. This reduces down to 1/2, so I could say there's a 1/2 chance, or I could say there's a 50% chance of that happening. Now the probability that it lands on a 7, well, we know that there are still 6 possible outcomes on the die, but one of them is not a 7. So in this case it's a 0. There's a 0% chance, or it's impossible for that outcome to occur. When I look down here and it says find the probability that you spin the spinner once and it lands on each of the following. Well, if I look at my spinner, I see that there are 8 different options, and that all of the options have the same amount of space or area taken up on that circle. So that means that they are all equally likely. So I know that my sample space is 8. So I know that's going to be my denominator of every single probability that I write down, of every single fraction. So the probability that I spin a red is something out of 8. And I can go through and look, and I see 3 of them. So my probability is 3 out of 8, which is approximately 38%. A number less than 10, well, if I look at those all have a value of less than 10. Which is 8 out of 8, which is 1, which is a 100% chance of happening. Every single time I spin, I will spin something less than 10. Red with an odd number. So I look at just my red spaces, only one of them has an odd number. And that is a 12.5% chance then of that occurring. Now sometimes it just wants me to leave it as a fraction, but I can also think about it as a percent or as a decimal. The probability that I will spin a yellow, this is like the 7 above. There are no yellows, so it's a 0%. This is impossible for it to happen. The probability of spinning a green, I see 2 greens, and once again I want to reduce when possible, so I get 1 out of 4, which I can also think about as 25%. The probability of blue with an odd number. I have 3 blues, but only 2 of them are odd. That also breaks down to 1/4 or 25%. Now I told you we were going to be talking about 2 different kinds of probability today, and probability is just the chance that something could occur. Now I have theoretical probability, and I'm going to compare it to experimental probability. So theoretical probability is based on what you can expect to happen. Like if I flip a coin, half the time it could land on heads, half the time it could land on tails. As opposed to actually flipping that coin, say 50 times, and then figuring out, well, did the heads or the tails actually occur more? That would be the experimental probability. The one that we're going to look at is boys versus girls being born. So this is kind of like flipping a coin. The chances of a boy versus a girl, well, there's only 2 outcomes. So when I look at that, they're all both going to be 1 out of 2, or a 50% chance of happening. They're equally likely. Births in 1 year, though, in the United States, when I take a look at that, if I do boys, so this is the experimental probability because this is what actually happened in 1 year. We had 2,110,558 boys born in this particular year. And there were a total of 4,138,349 births. So these are the boys, and this is the total number of births. When I do that, I get 51%. Now, my only other option was girls, so my percentage for my girls would be about 49%. Very close to a 50-50 on a very large scale. In some years you will see that flip-flop, some years there'll be more of a distance, but that's what happens when it's experimental. This is what is actually going on. It's based on actual outcomes of repeated trials and actions. All right, so another example that we can look at is classify the following as theoretical or experimental probability. A soccer player took 12 shots on goal and scored once. Well, since the soccer player actually did this, this is going to be experimental probability. And his probability is 1 out of 12, which is only about an 8% probability that he will score. Maybe you should have somebody else taking the shot on the goal, right? Just depends on what level he's playing at. Next one says you roll a standard number cube 50 times and get 8 threes. This is I've actually done it. So this is also going to be experimental. And 8 out of 50 is a 16% that it happened. And if I were to roll a number cube 1 time for a 3, I would get 1 out of 6, which would be 17%. So my theoretical probability was really close to my experimental probability. You choose 1 tulip at random from the vase, and they have 5 out of 12. This is theoretical. This is exactly what is going on here. There are 5 and there are 7. There are 12 total. So it isn't I've repeatedly pulled tulips out, and this is how many I got out of how many tries. This is what one time with all events likely possible. You're going to do some practice with this, and let us know if you have any questions.